All right, not a whole lot to review after Mr. Woodard's video. We're just going to jump right into how the vision system works. So again, the visual system is kind of like the dominant system as far as our senses are concerned. So Mr. Woodard talked about the McGurk effect. We've probably watched the video in class. So let's take a look at how the visual system actually creates color and how we actually see things. So first of all, and this is what I was referencing in our very first video in this chapter, how we don't see the world exactly as it is because our brains have a limited capacity to pick up the electromagnetic spectrum. So there's only a little sliver of the electromagnetic spectrum that we can actually see. So this slide is excellent for seeing that. You can see here if light comes in, hits hits the prism and comes in, this is the light that we can actually see here. But down on this little grid here, you can see that there is a lot more of the electromagnetic spectrum out there. We just can only see this little tiny sliver of it. It's kind of cool. You can Google like the sun seen through different areas of the electromagnetic spectrum. And there's a site I think that NASA has actually that has pictures of the sun, and they've colored it in so that our eyes can see it, but you can kind of get a feel for how it might look. Even if it wasn't colored in like that, you can see how it looks different than if we were just viewing the sun ourselves. Okay, physical property of waves. So light waves are coming in, and then it's going to be up to our eyeballs and our brains to make sense out of those waves. So with both vision and hearing, we've got to know terminology regarding the waves that are coming in, whether they be visual waves or they be sound waves. So the first term to know is frequency. Easy to remember. If you've got literal waves coming in, and they're coming in quite often, if they're coming in frequently, then what the frequency is here, you can see it with the arrow, is the distance between the tops of the two waves. So if you have high frequency, that means there's a lot of waves coming in. That means that the top of the waves are fairly close to one another. And you can think about that just like with ocean waves. If the ocean waves are coming in really fast, then you don't have a lot of time to get out of the way of the next wave because they're coming in fast. If the frequency is very low, then you're going to have a longer distance between the tops of the waves. And you can see here that with vision, that translates to the types of colors that we see. So if a wave coming in, if a visual wave coming in has high frequency, we're going to see bluish colors. If it has a lower frequency, we're going to see reddish colors. Then the other term that we want to know is amplitude, and this is just how tall the wave is. I always think about it in terms of musical instruments. If you set up the amp and you turn it up really loud, you're going to hear really loud music, right? So the greater the amplitude, the higher the wave. For vision, if we have a great amplitude, if we have a higher amplitude, we're going to see brighter colors. Oops, sorry about that. And if we have a smaller amplitude, we're going to see duller colors. I don't recall AP exam asking about amplitude and frequency as they pertain to the types of colors that we see, but I wouldn't put it past them, and I very well could be wrong. There could have been a question about that. They will ask about frequency or amplitude. They do like questions about that. Okay. You're not going to right now take a few minutes to draw this, but I do think after we're done watching the video, you should take some time to do this. I'm going to take you through some of the main structures of the eye, and then it will be very, very beneficial for you to go back through and actually draw these out and take some notes. So the first structure is the cornea. This is the outer covering of the eye. Now with the cornea, most of the time we hear about this like people will get a scratched cornea, and it's really bothersome. It feels like you have to itch your eye. It can be a little painful. It can take a while to heal. Okay, so the cornea is the very outer covering of the eye. This up here. The pupil is, of course, the adjustable opening in the eye, that black part of the eye that will get big or small, and it's letting light in when it gets a little bit bigger, or it's trying to close some of that light out when it gets smaller. You might have done that in elementary school where you sat and looked at somebody's eyes and turned on the lights in the classroom and watched the pupil go up and down. Okay. The iris actually is what gives us color in our eye. And the iris is a muscle, and that muscle is actually the thing that's controlling the pupil opening and closing. So when you get your eyes dilated at the eye doctors, what they're doing is they're actually putting a substance in the eye that is blocking some of the receptors of the iris. And so the pupil can't open and close. It just has to, or I should say it can't close. It can't constrict. So it just stays open and dilated. So the iris is what controls the pupil opening and closing. It's actually a muscle. The lens is this piece here, which is right behind the pupil. And the lens is going to change shape to help focus images back here to the retina, which I'll talk about here in a second. Now, this one's kind of an interesting one for me because just a few days ago I had to go to the eye doctor, and I still have 20/20 vision. My eyes are very, very healthy, but I'm straining a little bit more when I'm working and when I'm reading. And I asked the eye doctor about that, and she said, you know what? What's happening is as we age, the lens becomes a little less pliable. It becomes a little stiffer. So what's happening here is I'm straining a little bit more because that lens isn't really, it's not working as easily as it did when I was younger. So I have to strain just a little bit extra. I can still see just fine, and a big piece here is this accommodation. That lens will change shape depending on where an object is. And even you with young eyes can do this. If you're looking at something like the screen up close and then you look up at something far away, there's that little moment of blurriness, right? Well, that's the accommodation. The lens is changing shape to get things refocused from a farther distance. Okay? My lens just has to work a little harder because I'm getting a little older. The retina is in the back here, and this is going to contain what are called rods and cones. And the rods and cones help us to either see at night or in the daylight, pick up color. I'll talk about rods and cones here in a second. So what's happening is, and this picture does it with a candle. Candles are pretty common to use with these examples. If you're looking at a candle, that light is coming in. And just the whole thing. I'm seeing the candle and the candlelight, and it's coming in, and it actually gets bent. The light gets bent a couple of times, and when it's thrown to the back of the eye, it actually turns upside down. It's our brain that reverses it right side up. More on that later. So the light comes in, it gets cast through the lens to the back of the eye into the retina, and the retina then is going to send it through a series of nerve cells that will eventually help us to see that, or send it to our brain for transduction to occur, for our brains to make sense of what we're looking at. The fovea is the central part where this should be focused at. It's the point of central focus. Move it down a little bit. So as this light is cast through the pupil and the lens, it's thrown back to the fovea, and this is where we can focus. Now, this is kind of interesting. If somebody has an eye that's a little bit longer from front to back, everything here is still working exactly the same. It's casting the light to the back of the eye. Problem is, if the eye is a little bit longer, it's going to end up casting the image a little bit further ahead because it wants to go the same distance, but the eye is too long. And so what happens is you end up having trouble seeing things from that are distant. That's what nearsightedness is. The eye is just a little bit longer, so the image is cast a little too far forward in the eye. What if the eye is a little bit shorter? The eye is a little bit shorter, but everything's working exactly the same. The image is actually being cast a little too far away. That's what we call farsightedness. It's hard to see things that are up close because this is getting cast a little too far back. And that's what what contacts and glasses will do. They'll change the curvature and the bend of the light in order for it to focus right on the back of the eye and the fovea. Okay, I'm going to stop there. Mr. Woodard will take over with rods and cones. That's kind of the basic structures of the eye. Mr. Woodard will add a few more here and probably talk about transduction.